Okay, so yeah, we're gonna finish the first equation today, and then I'm gonna show you how to do exam problems, and why basically different equations sometimes might be really easy to solve. Okay, so let's do like a 1 minute recap of what we learned. We learned what differential equations actually are, with that useless definition that you're never going to use in your entire life. Basically, a differential equation is an equation that has derivative in it. Absolutely useless. Never going to use that definition in your life. But it's the formal definition, so nothing I can do. And then we learn linear ordinary differential equation. Okay, this you might use that. We learn how to solve them, and I hope everyone is convinced at this point that it's completely like up to the derivative at the end that you need to compute. It is completely telegraphed. It's the same every time, so don't need to stress about it. The problem with this differential equation is that, as you saw, it's maybe too telegraphed. It's maybe too scripted. It's maybe too the same every time. So that's why you need to learn in this class the separable differential equation, which I have seen more on the exam, but again, there's no rule to it. I'll probably hint if I need this was on the exam, but I actually have no idea. So, okay, so we're going to separable differential equation. First of all, let's establish how it looks like. It looks something like this: x f of x, g of t. Okay, what's the idea behind it? It's separable. You can separate it into something that depends only on t, depends only on t, depends only on x. Separable, two different things. Got it? Okay. Now, how do you solve these? It's not actually, like, as I said from the beginning, it all comes down to an integral. But, we're just going to do it a little bit formally. So, the first thing that you need to do in this case, the first thing, always do this, because sometimes it might just give you the solution you're looking for, and sometimes it might just work out faster than you expected. So, the first thing to look at is this. Wait 1 second. Let me see if this is annotation in your book. Let me try to find one. Okay. Yeah. Apparently, it's this. Is you put your f. It doesn't matter, of course, but this is your f, and this is your g. So I'll just write it again after I completely messed it up. But this is your g of x in the book, and this is your f of t in the book. Same concept, of course. Just the functions are inverted. Okay, so the first thing that you need to do in this case is to check constant solution. Okay, how do you do that? You basically just look at g of x is equal to 0. Okay, you're basically just going to solve this g of x is equal to 0. And you're gonna get some solution. I don't know, maybe g of 5 is equal to 0. Okay. At that point, what's the idea? If x, this implies obviously that x is gonna be x of t is equal to 5. If this is the truth, if this works out, or any number probably, I don't know by heart, it depends on the equation. What's the idea here? That this x dot, remember, is the derivative of x with respect to t, has to be equal to g of x f of t. Now, for 5, you're going to have derivative of 5 with respect to t is equal to g of 5 times f of t. Right? Let's try for 5. Like, why does the solution work? Well, the idea is that what's the derivative of 5 with respect to t? that's just 0. 5 is a constant, right? So this is just going to be 0 is equal to g of 5 is 0 because that's how I found it. And then it's f of t. And this is true. So that's why this is a solution in itself. All right, so this is the first thing you need to do. You need to check for constant solution. The problem might even ask you, if they're nice, what are the constant solutions of this differential equation? At which point they're basically asking you to check the solutions for g of x equal to 0. Okay? You don't need to memorize this because the way you actually solve this, the way you solve it is separable. You know, if it's separable, it means you need to separate. Make sense? Kind of, right? So if I have x dot is equal to g of x times f of t, then the idea is to just write x dot, I'll move up right now, over g of x is equal to f of t. Okay? And now I hope it makes sense why I need to check for g of x 0 before. Because I can't divide by a 0. It just doesn't work. That's why it makes sense for me to check g of x before. Okay? And now the formal kind of definition is I'll write more or less the formal definition. But the idea is that if these are equal, then their integrals are equal. X dot g of x is equal to integral f of t. That's kind of the idea. Now, one thing that I'm missing and I did not write is the d of x dt, the d thing. Because remember the variable, the usual integral looks like something like integral d something here. I don't have this part. Why? Because I want to show you how you get it. You don't need to memorize it by any means, but it's just it's just nice. The idea is that this x dot is dx dt over gx, and this is just f of t, integral. And the idea is, okay, with no integrals before, so I can show you the proof actually. And then the idea is that you can move this dt on the other side, and you get dx gx is equal to ft dt. And now when you integrate, you get everything nice. You get 1 over gx dx is equal to integral f of t dt. Okay, it's just works like magic. But basically, you don't need to worry about this fraction that I wrote or how to obtain this or moving it. You just need to know that once you have identified g of x and f of t, you need to compute this integral. You need to compute these two integrals. And idea is that once you're done with this, the problem is done, because from here you get a solution for x. Now its idea is that after computing the integral, the two integrals, I guess, you are done. Okay, and you can write x of t as being something. And so the procedure, I think, is rather simple. Again, it's just a matter of computing the integral. Usually on these, when you're gonna have something like this, one of them is gonna be really easy, one of them is gonna be a little bit not easy. So that's kind of the basic. And then of course, if I'm asking you if I am asking for a particular solution, for example, x of 1 is equal to 1000, you do the same thing, as we did for linear. What is that same thing? It's basically just you plug t equals 1 and you get the constant for that being 1000. So you basically just do the exact same thing. Now, realistically, this is all the theory there is for separable. There's nothing else. So now we're gonna take examples and hopefully make it work. Let me see if I can find like yeah, let me see if I can find something that looks nice that we can solve. Okay, this looks good. Not really sure. Okay, so any questions on this? Or maybe more questions after the first example. The first example I'm going to think of is x dot is equal to e t plus x. Okay. Cool. Let's see what we have here. So we're going to proceed exactly like, okay, almost exactly like we did in the linear, which is first we write our function in the exact same way that we know a separable one needs to look. So I know that the separable needs to look something like this. Okay. At this point, the function above does not look like something like this. So what can I do? I can just rewrite it slightly different. I can just write it as x dot is equal to e to the power of t times e to the power of x. Fair? And now I can identify. Once you've reached the shape, the form of the differential equations that resembles what we did in class, you can identify and then you can start computing the integral. And that's literally it. There's nothing more to it. So let's do it. We identified g of x is equal to e to the power of x, f of t is equal to e to the power of t. Good. What's our first step? First step is checking solutions. G of x is equal to 0. Checking constant solutions. Okay. What are we doing here? Checking constant solutions. Okay. We're putting g of x equal to 0. What does this mean? G of x is equal to e of x. So it means e of x is equal to 0. This is not possible. Okay. Not possible. So no constant solution. Okay. Cool. Now we move to step 2, which is now you don't need to give me all the proof. You don't need to, again, you can just use the formula or something, which is that this is the one. Yeah. You can just use this formula over here. This one over here. Once you've identified your stuff, I don't know if this is going to be on the cheat sheet. I'm assuming 99% is going to be on the cheat sheet. So, yeah. But the idea is that once I have identified my stuff, and I'll write them again. G of x is equal to e to the power of x, and f of t is equal to e to the power of t. I know that the integral of 1 gx dx is equal to integral ft dt. Okay, plug in and get on computing. Of course, I gave an easy example for myself because I kept the hard one for you guys because that's completely fair. Just like it's going to be on the exam. Okay, I just put my stuff in, and now I compute. This is integral e minus x dx. This is just, let's keep integral et dt. And now, this is just minus e minus x. And here's one thing. You can put a C1 here equals to integral of et plus C2. But again, these two numbers are constants. So, and they're just influencing the same way, or they just look the same. So you don't need to put two of them. You can just put one and it's enough. So I'll just put one because it's more than enough. Okay. Good. Now, you are not done here, really. Because remember, for you to skip to solve this, the solution needs to look x of t is equal to something. Okay, that is the final solution. That is what it needs to look like. So what we're going to do here, we're just going to play a little bit here so we get the right solution. So I'm just going to get e minus x is equal to minus e to the power of t minus constant. Minus x is just equal to ln. I take up ln of everything here. Okay, so x is equal to minus ln x of t here is equal to this thing minus a constant. And I'm done. Okay, any questions here on what I did? So again, procedure, again, it's scripted, but you don't, the difference is that in the linear case, you automatically get the formula for it. Here, you don't really get the formula for it. You just get two integrals that you need to compute. So that's kind of different. But in terms of how to solve it, I think it's, again, very, very scripted in the sense that you're given a differential equation, which obviously might look way out here than that. And at that point, you just remember how the general form looks like. You identify your g of x and f of t. And I would recommend taking this part slow, because if you mess up the identification, you are never going to solve the integral. And if you're going to solve it, you're going to solve the wrong one. So take your time in identifying correctly. Make sure everything is correct with this g of x and f of t. It looks like something a child might do, but if you mess up, you're gonna come solve. It's gonna be really bad. Bottom line. Okay. So now, once you've identified your stuff, you check for constant solution. Check for constant solutions. Fancy term. Just try to see what x gives you. Gives you g of x is 0. Once you've done that, if their solution's good, if there are no solutions, same thing. It doesn't matter for you. You just need to show the grader that you took that into consideration. Okay. After this, you just use this formula, or you can like prove it yourself if you want. I don't know, it doesn't matter. I use the formula, and you get this. You get that these two integrals have to be equal. You just replace with like g of x and f of t. You replace them, and then you do your best to solve these two integrals. That is the complete roadmap of how you deal with these equations. And eventually, keep in mind that your answer needs to look like this. Because they're asking the solution for x. They're not asking the solution for e to the minus x or something like that. They're asking solution for x. So your solution needs to be clear that this is the solution. Okay? Fair? Good. Now, as I said, if they're asking, in this case, I computed the general solution. So my general solution looks like this. General solution is x of t minus ln minus et minus c. Okay. And then the problem asked me to compute particular solution for x of 1 is equal to minus ln of 1. Just because, yeah. Now, what you do here, as I said, you do exactly like we did in the linear. Plug in t equals 1, and you get x of 1 is equal to minus ln of minus e minus the constant, which again, it's just a matter of finding out this constant, is equal to minus ln of 20. At this point, minus e minus the constant has to be 20. So the constant is just minus 20 plus e. Okay. Hopefully it's correct. Oh. Minus e, okay. Math is hard. Okay, so you get this constant, and then you just plug it in again, and the final thing, minus ln minus et minus or plus 20 plus e, whatever. Okay. And now you're done with completely everything. You computed a particular solution. Yeah, particular solution. For x1 equals minus ln 20. Okay. Cool. So any questions on how we deal with these things? I know I don't know how you can solve the integrals that you're gonna get. That's not really something I can help with. Let's see if we can find something more interesting before we jump to the exam. Okay, this one is interesting. I don't know even if I can solve it. Okay, let's see. So this was. Okay, so now the one we're gonna solve is called, for those of you that are gonna do economics or whatever, it's called logistic growth. Sounds something like macro, but something that we use in macro. I don't know, I don't study macro, so not really. Okay, so your differential equation is this: x dot is equal to r x 1 minus x over k, with the condition that r and k are bigger than 0 constant. This is called logistic growth. I have no idea where it's being used in economics, but it's definitely being used so. Okay, now what's the first step that we need to do? Again, it's not something new. We need to identify our part. Okay, so I write it out. My x dot, I know it has to look with, remember I think it's gx times f of t. Okay, this is how it needs to look. Now, in this case, it's a little bit trickier. Why? What's the identification here? What is f of t? Exactly. Well, that's the point. There's no t. Okay, you don't need to panic about it. There's no t. So, identifying. What do I get? I just get g of x is equal to this whole thing. Okay? And I get f of t is equal to 1. There simply is no t there. Okay? Works for me. As I said, one of the integrals is going to be hard, one of them is going to be easy. Obviously, the one integral of 1 is going to be easy. Okay. Now, we got this. We identified our parts. We double check it makes sense. There's no t here. There's no x here. Looks about right to me. Now, one question. Can you put the r from here? Yeah, of course. But it's not going to matter because it's a constant, right? When you integrate, it's just going to jump in front of the integral anyway. So it's not going to make a difference. I'll show you what I mean. Okay, first step. Check g of x is equal to 0. Constant solution. Okay? In this case, I have r x 1 minus x over k is equal to 0. In this case, I can sense 2 solutions. Okay? So 2 solutions. First is x is equal to 0. That works just fine. And then second is 1 minus x k is equal to 0. You know, like if the product of 2 numbers is 0, it's 0, then either this is 0 or this is 0. That's basically what I'm saying here. So this is equivalent to saying x of t is equal to 0, and then x of t is equal to k. Okay, if it's k here, this is 1 minus 1 is 0. Okay, so I got 2 solutions in this case. What do I do with them? Absolutely nothing. I just move on. Okay. I wrote them down. I got two solutions. I'm good. I'm good to go. Okay. Now, any questions of what I did here? Okay. So what's happening now? I'm going to rewrite my functions so you guys can see them, or attempt to see them at least. G of x, Rx, 1, xk, f of t is equal to 1. Clear, clean. Okay, now our integral was 1 gx dx is equal to integral f of t dt. Okay, and we are going to write, like, just so you're convinced that constants when you're splitting it do not matter. Like you count when you're splitting the two functions, it doesn't matter where you put the constant. If you put the constant on the t part or the other part. Let's say I identified, so this is my first case, and let's say, you know, my colleague identified it this way, x1, x over k, and f of t is equal to r. First of all, is this a correct identification? Well, sure, why not? This depends on x, no t. Sorry, this depends on x, no t. This doesn't depend on x, depends only on t. So it's a good identification. So let's see. I just want to convince you that these two solutions, if you identify these two identifications, are going to be the same solution. You don't need to worry about constants. The constants don't matter where, or you know, in which are, if they're in F or in G. That's my point. So let's do the first case. The first case, so I'll just put 1. First case is going to be integral of 1 over Rx 1 minus x over k dx is equal to integral 1 dt. Remember, I said usually you're going to have one harder, one easy. That's just how it's going to work. Okay, so I can just put this is a constant, r is a constant, so I can just write it as 1 over r integral 1 x 1 minus x over k dx is equal to integral 1 dt. Okay, this is what I need to solve in the first case, and we're going to solve it, no worries. But let's first look at the second case. What I would get in the second case if I did the second identification. Remember, this was my identification in the second case. Okay, so the way it would look, it would be in the second case, it would just be integral of 1 x 1 minus x over k dx is equal to integral r dt. Now I can just put the r in front. I get 1 x minus k dx is equal to r integral 1 dt. Now let me see if I can make it look nice. Okay. Now everyone is convinced that these two equations are exactly the same. It's just moving the r from one side to the other. Okay? They are exactly the same thing. And that's why, again, do not stress of how you split the constant. That does not matter when you're computing something. Okay. Again, it doesn't matter which one we solve. Well, let's keep on solving here. Okay, we think about it for a second. And you still think about it, but I still have no idea. And then let's see. If I just multiply this fraction by k, okay, I get integral k x 1 minus x K dx is equal to, what is the right hand side? Is just, that's just t. Integral of 1 is just t plus constant. Okay? So now I need to solve the left hand side. I have an idea. What if I multiply this with this? I multiply them, right? So I just get integral k x, and I get k times 1 minus x over k times k. Dx still equal to RT plus the constant. Okay? What's the nice thing about it? This goes away, this goes away. And I just have integral k x k minus x dx is equal to RT plus a constant. Now, how many of you remember the formula for this fraction, how to split it? I think I wrote it in class, and but I definitely wrote it in the seminar, so I'll rewrite it again, because this is really, really useful. The formula that I'm talking about is, let's give the simplest version out first. The simplest is, if I have k and I have 1 x plus k, this is equal to 1 over x minus 1 x plus k. Okay? This is just math. But the idea is that if you don't know this formula, coming up with the idea and the exam of this formula is a little bit of a struggle. Like, I wouldn't be able to come up with the idea of it. Let's take an example. What do I mean by that? For example, 2 over x plus 2 is just 1 over x minus 1 x plus 3. Let's push it up a little notch. 3 x minus 1 x plus 2 is equal to x minus 1 x plus 2. Okay? It's just really, really, really strong, like extremely strong. In the sense that I probably wouldn't solve half of the integrals I do if I didn't know this. But if you guys have another method, just go for it. I'm just going to use this. And I see the compendium, I think, uses it a couple of times, because I have no idea how else they would solve it without using it. But they don't write the solutions down. Anyway, so my integral is this: k x k minus x dx. So I have in mind that formula. I'm thinking of how I can use that formula. So I'll just write this as, put a minus. This is minus integral k x minus k dx. I just thought of it. Why not? Let's put it like this. Okay? And now I just know that this thing, according to this ugly formula that I just wrote up top, this is just equal to minus integral 1 over x minus k minus 1 over x dx. And why have I bugged you with this formula? Why does it make sense? Because once you reach this writing, each of these fractions is easy integrable. It's just ln of that thing. So this is just equal to minus and integral 1 x minus k dx minus integral 1 over x dx. And as I said, these are just really, really nice integrals. This is just minus ln x minus k plus ln. Right, just these things like that. Okay, any questions on this? Again, I think the trick part is, again, this formula over here, which I have used in many, many circumstances for success. And I would recommend, I think, I don't know, I was told that you guys know this very well, but yeah, so apologies for those that I'm boring with this. I'm getting bored with it. Anyway, so now I solved the left-hand side of my equation. I solved this part over here. I did nothing to this thing, and I don't need to do anything to it. So I'm just copying the result. Minus ln x minus k plus ln of x is equal to RT plus the constant. Okay. Remember, I am not done yet. I need that x of t being equal to something. So at this point, I have no idea. I'm just playing around with these things. I'm just struggling to get something out of here. You know, I kind of feel like exactly like you guys on the exam. I'm just trying at this point. So I know the formula ln of a minus ln of b. That's just ln of a over b. So I just use it here. This is ln of x minus k is equal to RT plus a constant. So this is just ln of actually let's just raise everything to the power. This makes more sense. I think it might be easier. So x minus k is equal to e to this power RT plus the constant here. This is the definition of ln. And I'll write it again, the formula. If ln of a is equal to b, then a is equal to e to the power of b. Okay, that's just the definition of ln and exponential. This should be really familiar from Mach 1, I guess. Okay, and now for me to get x out of here, x minus k plus k, I just simplify this fraction because that's all that I can do. And I get 1 plus k x minus k e r t plus constant. And again, it might seem more complicated than this, but it's just dragging it out basically. You get the solution from here. It's just, let's write it step by step. X minus k e r t plus constant minus 1. So k over e r t plus constant minus 1 is equal to x minus k. So finally, after all this work, I get the solution. This was actually really, really good. And you get this solution and you are done. The sad part is that probably if you have gotten to this part over here, you would have already probably got most of the points. I think this part here is a little bit unnecessary, and I hope there's not going to be something like that on the exam, where you just have to play with the fraction until you get x of t out, because it's clear that you know what you're doing if you got to this part over here. Okay, but this is the general solution. Okay, and again, pretty standard. If I wanted to check x of 1 is equal to 200, just plug in t equals 1. I'm not going to do that. And if you got the idea of what you need to do, then just don't do it, because you need to get the c out of here. You need to get this c out of here. So that's going to be a little bit of computation, but that's besides the point of how to solve separable differential equations. So on the time, let's take a 15-minute break right now, and then we're going to do exam problems. Show exactly what I mean by this. Okay, I think 15 minutes are up, so let's get back to it. These are 3 of the problems that I want to do. They're just exam problems that were given on the exam, and they're really, really nice because for you to solve the differential equation in that exam, you didn't need to do any integral outside of integral of 1 from of 1 dt or something like that. So it's really, really simple. And I'll show you what I mean. But first, just so we're clear about it, like we receive questions, just so we're clear about it. You are checking in the first time, you're always checking g of x is equal to 0. And then you, because you are, you've checked this case, you then can check the case of g of x is not equal to 0, in which you do the whole integral of 1 gx dx. Integral f of t dt. It really, again, really important to check these solutions because, let me see. I think in the previous example, let me see if I can find it for a second. The previous example. Okay, yeah, because in the previous example, right? Like in the previous example, we found that x1 minus x over k is equal to 0. So we got the solution x is equal to 0 and x is equal to k. Okay, we got these two solutions from checking being equal to 0. I want to draw your attention to the fact that in the general solution, which is this, which we got k plus k over ERT plus of that. Okay, yeah, thanks. Okay, so again, really, really important to not skip this step because you are missing out on extra solution. Cool. Now let's do the exam problems. So let's do 2 from 2017. From 2017, we bring it up in a second. I might have done this in the break, but I need to break as well. Yeah.
So the are
No, the constant solutions are just solutions in themselves. So in this case, I would have. Oh, let me bring it up. Great question. In this case, I would have solution being x, x of t is equal to 0, x of t is equal to k, and x of t is equal to this thing. Those are like my 3 solutions if you want to consider that. Okay? Because they all work and they're all different. That's the whole idea. But again, this g of x equals 0 gives you some extra solutions, so don't skip on it. Let's see. Exams. I said 2017 too. So that is okay. Previous exam, 2017 too. Which one? This one? Yeah, it was this one. Okay. It's somewhat perfect. It looks absolutely horrible. Was it actually this one? 1 second. Because I have some salvation from what I did at some point. It was definitely not this one. It was uglier, actually. Yeah, here, see, this is the one. Problem number 2 here. And why am I saying that you don't need to solve any integral? Where? Well, you can use everything that you solved before that. So let's copy B, okay? I'm gonna copy B just so we know where we're at. So P and Q, whatever, dot, 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 such that P integral of T e minus 1. We've done this integral at some point, I'm fairly confident. dt te plus ln of t plus a constant. Okay, good. So we have this for part B, and then they're asking us to whatever solve this, etc., etc. X of t is equal to t e minus 1 ln e squared t e minus 1 x squared. Okay. So that is part B, in which they're asking us to get some PQ such that that thing holds. And this is my part C. Okay, I need to solve part C. And here comes the thing that I told you before. Even if you didn't solve part B, you can use the result from part B in part C, for example, and you will get actually full credit for it. Okay, so first of all, let's solve our equation. We'll look at it for a second, analyze it for a second, and we know that my form has to be x of t, and I'm really careful right now, or pretending to be careful, f of t times g of x. We look at it, and we kind of identify this being equal to this, and this being equal to this. So I get f of t is equal to integral of, no integral, sorry about that, I don't know, I'm thinking. T e minus 1, ln e squared, e minus 1. Okay, and g of x is equal to x squared. Did everyone manage to identify or follow while I'm doing that? Okay, I just looked at my shape, wrote my general formula, and then I know it looks very, very ugly, so I'm just trying to not think of it. And I'm just identifying my part. I'm just going through the movement. Identify. Cool. What's the next step? Next step is check g of x is equal to 0. G of x is equal to 0. X squared is equal to 0. X of t is equal to 0. Boom. I have a solution. Do I do anything with it? Absolutely nothing, but at least I got a solution. Okay? Now, what's next? I have identified f of t. I have identified g of x. I can just write the integral thing. Integral 1 gx dx is equal to integral f of t dt. Okay, apply the formula. Apply the formula, g of x, replace it, integral 1 x squared dx is equal to integral, something very, very ugly here, t e minus 1 ln e squared t e minus 1 dt. Okay, we are, and now we can compute the left-hand side. We can compute this. This is minus 1 over x dx. No, obviously no dx, sorry about that. This is minus 1 over x. But this thing, this is a problem. This, I have no idea how to solve. And here is where part B comes into play. I don't need to solve it. Let's look at part B. Let me see if I can. This one is broken. Okay. Let's look at part B. It's the same exact integral. You know, just take your time if you want to convince yourself. It's the same exact integral. So now I can just use the result from part B. And I can even keep the P and Q there. It doesn't matter. I'll just keep them there. For the P and Q for B, from B. I already lost points for not solving B. So I can just use it here. And now, what do I get here? Again, I'm just going to copy this. Remember, there's a P in front here, so I just put it on the other side. And I get minus 1 over x is equal to 1 over P, and I start copying. T to the power of E, Q plus ln of T plus constant. Done copying. At this point, what am I doing now? Just x of t is just equal to minus 1 over p te q plus ln t plus constant. Hopefully I didn't mess this up, but I think it's correct. Okay, done. Problem is solved. I didn't solve any integral. I get maximum point. Okay. That's something that I want to show, and I think it's pretty recurring. Because solving an integral does take some time, especially if you're new to it, as you guys are this year. So I'm not really expecting you to get to solve two completely different integrals. I'm not expecting you to get to solve an integral separately in part A and then get in part B a completely different integral. I'm not really seeing that happen. I definitely see something similar happening. We're gonna use part A to part B. So you just gotta keep your eyes open and see it. But again, I have solved this problem, and the only integral I have computed is this integral of 1 over x squared, which I hopefully is not a problem for anyone. Okay, perfect. Any questions on this? Okay. Sure. Yeah, I'm just saying that if they give you something like show that the integral is equal to this, and then in part B they give you like a differential equation. I'm not saying that it's gonna solve like this, but I'm just saying I have like a feeling that is saying it's gonna solve like that. Okay. So it's just how it works in the exams. I don't know. You get that feeling after you've done a lot of exercise. Now, next problem is problem 2 from 2018. We go to 2018 now. Oh, was the ugly one? Good. Oh, okay. Here, this one. Yep, it's this one. Okay. Awesome. So excited. Let's do this. Part B. I'm going to copy again part B while you guys read that. B is B is whatever. Yeah, okay, let's copy it. Okay, so I have integral x1. I'm just gonna copy it so you guys don't have to, but you know what? Well, I'm copying it. I just had an idea. Well, I'm copying it. How about you guys take 7 minutes to see if you could solve point C. Point C, again, the differential equation. Find the general solution of the differential equation this way. How about you guys solve that while I'm copying here? So we're all productive. I kind of feel abused right here.
I know it looks kind of bad, but just, take it step by step. See where you get. You never know where you're gonna get stuck if you don't stop.
Yeah.
It's kind of start with here. The right side.
Yeah. I mean, it's clearly not supposed to be there. Yeah. I'll take care of it. Okay, but then it's not there. Okay. Okay, how did we feel about this problem? Good, bad, average? Okay, we'll take it. Okay, so what is the first step? Again, I'm not reinventing the wheel here. I'm just basically doing everything that we did for the others again. What is the first step? Trying to identify stuff. G of x, f of t. I look for a second, take 1 minute to identify correctly. This thing has only x, so I give it to x. This thing has only t, so I give it to f of t. Okay? G of x equals x1 minus ln of x. F of t is equal e t ln of 1 plus e t, everything squared. Okay? This step, hopefully everyone got. Now, what do we next? What do we do next? Pretty standard, check constant. G of x is equal to x1 minus ln of x. Well, if this needs to be 0, then I have case 1, x is 0. Case 2, 1 minus ln of x is 0, which is the same as saying x has to be equal to e. Okay? Because ln of ln of x has to be 1, so it's just e. Okay, now, have I found solution? Apparently yes, but if you look at the problem, the answer is no. Why? Not good. Why? Because x is supposed to be in 0e, open. It's written right here. Valid for x 0e. Okay? So, not good. because x is in 0 and e. It's open, so it means x can't be 0 and x can't be e. So I found a constant solution. That's no problem. We move on next. Okay. Moving on. What do we have? We have integral of 1 gx dx is equal to integral ft dt. Just applying the definition. Now I'm replacing my stuff. Integral 1 x 1 minus ln of x dx is equal to integral of et ln 1 plus et everything squared dt. Okay, I literally just plug in my g of x and f of t. And now, before you panic, look at point B. Why do we have point B? Well, I have this one to compute first. We look at point B. Not always the same, doesn't it? Okay. So this is just ln of 1 minus ln of x. This thing. What is this thing? What is this integral? That looks even uglier. We check it up. Looks kind of the same as this one, doesn't it? Et ln of 1t, ev ln of 1 plus ev. Yeah, it's the same one. Exact same thing. So I know this is equal to just something really ugly. I'm copying. I move this 1/2 on the other side. And I get 2 times something really ugly. 1 plus et ln of 1 plus et minus 1 plus. Are we more or less done? Yeah, kind of. We just need to get that x out of there. That is the only challenge I have left. No integral computation. Yeah. That is a great question, actually. It is a great question. It is actually a perfect question. Okay, so let me solve this and then I'll answer that question, okay? But that is a perfect question. So all that I have to do now is get the x out of here. And how do I get it? I just use the fact that ln of a equal b. It means that a is equal to e to the power of b. So I just keep on doing that on repeat. 1 minus ln of x is equal to e to this whole thing here. Again, if you're lazy like I am, you could just say, just put this as an a and just, I don't care about it. The grader will understand because you're basically just copying everything out right now. It's not like we're doing something really smart. Like the hard part was actually getting here. Plus constant is equal to ln of x, and then x of t is just equal to e to the power of this thing, power here, okay? And you're done. And I didn't need to compute any integral. Any questions on this? And then I'll address the question that I got there. Okay, no questions on how I solve this. Again, all I'm trying to show is that in some cases you just need to know the theory behind it, basically. And I didn't do any computation. And even if I stop here, if point C had 10 points, I would have probably gotten like 7 or 8 for literally nothing. So that's what I'm saying. It's just sometimes it's just simple as they get. Okay, now addressing that question. The question I got for everyone is I have integral. I I have integral from, I think it was, is it x to 1 or x1 to x? I think it's x to 1, doesn't matter. 1 u 1 minus ln of u. This is equal to ln of 1 minus ln of 1 of x, sorry. And the question I got here is, this is a definite integral. How do I know, you know, because I replaced immediately there. I just said this is the antiderivative, like it was an indefinite one. How do I know that I can just do that? And the answer is, you can't know for sure, but you can think about it this way. So 2 steps in checking. If you have a definite equal to that, 2 steps of checking. First step, easiest and most straightforward is take a derivative of ln 1 minus ln of u du and see if it's equal to that thing. Okay, that would be the definition of the integral. So check the definition. First check. Particularly, I'm not saying you need to do this on the exam because you don't need to. Okay. The way I did it, because I obviously didn't compute this in my head. Oh, maybe. But the reason, the way I did it was I thought of it this way. If this, you know, like this integral 1x1 u1 minus ln of u, this is some more informal, but since it's not graded, you don't get extra points for showing this up top. You can think of it this way. This is just going to be equal to some big f of 1 minus some big f of x. Fair? It's just when I integrate, I don't know. With the property that derivative f prime of u is equal to 1 u minus ln of u. Yes. Okay, just the definition of the derivative. So f is the antiderivative, the function I'm looking for. The derivative needs to be that. And the way I thought about it is, what happens if I put 1 here? And I will get ln of 1 minus ln of 1. This is 0, so I get ln of 1. If this is 0, so it means that f of x is just this thing, well, with a minus, but you know, I would have probably lost the point here myself, but it happens. So I can just conclude that minus f of x is equal to ln of 1 minus ln of x. Okay. So I was supposed to put a minus. Well, it happens. So that's nice. Again, but that's kind of my logic. The second one is what went through my head when I saw that thing. Honestly, it didn't go too well through my head because I missed the minus, but you know, everyone makes mistakes. Does this answer your question now? Okay. So again, the formal proof, if you want to like be 100% sure and you have some time to spare and the derivative is not too ugly, you can just take a derivative of the right-hand side and see if it's what's underneath the integral. That is like undoubtedly going to give you the correct answer. If you're more lazy like I am, you have this idea in your head that that the definite integral by definition is equal to f of 1 minus f of x, where f is the antiderivative. So I'm just thinking if this is, what if this is just x and I plug in 1 and I see it works out. But yeah. Any questions on this one in particular? Any other question? If not, we're going to move to the last exam problem, which again, I have a feeling it doesn't require any computation on your side. It's just a matter of keeping your calm and identifying stuff. You got to imagine these are literally 10 points, which you can get, especially you can get probably in the first 15 minutes without actually solving more or less anything. And then you're more relaxed with the rest of the exam. To 2016. And again, we're going to do the thing where I copy and you guys work it out. I think it's good. Okay, let me see if this is the one I wanted to do. Oh. Let me see. I have some sketches at some point. This is the one really. Oh. Oh. Is this the one? This was, oh yeah, well, this is the one. Okay. But this problem is not even tricky because it basically tells you to use point C or, yeah, whatever. But, okay, we're gonna solve point D, just the first one. Point D, just the first one. I think they're too nice here with you guys. They even give you the whole, they even split it for you guys. They even do it like, they almost do it for you guys and say, just write it down. Okay. Okay, guys, where are we at? So they kind of give you half the problem, I would say, which is the identification. All right, so they gave you this thing over here. They told you x dot is equal to ft times ex. I'm gonna act smart and say, let's identify. F of t, g of x. Well, good job. I found that g of x is equal to e of x. And f of t is equal to f of t. I know this looks very smart, but okay. Cool. What's our first step? Always check g of x is equal to 0. G of x is equal to 0 means e of x is equal to 0. This is not happening. No solution here. Minus infinity is not a number, in case you were wondering. So no, there's no solution here. Good. Now, what we have left to do, integral of 1 dx dx is equal to integral f of t dt. Now, 1 gx, this is just, we'll leave the right hand side for a second because we're trying to avoid it as much as possible. So, okay. This is just equal to minus e minus x is equal to this thing, which is just t, what is that? T minus 1. F of t is just t minus 1 minus m l ln of t dt. This is your f of t, and it looks absolutely horrible. I wouldn't want to solve that. So we need to look for something else. We need to look for some trick. And they tell us you can use point B. Now, here comes the question that I was asked before. Here is actually more relevant than ever. Because if you look at the thing, you get integral 2m of integral from t to infinity is equal to this thing. And that is like, you can automatically assume that this right hand side is just the derivative of f of t, but you're basically gambling at that point. There's no certainty there. Yeah. Oh, so I too late. Okay. Okay. No, it makes sense. It makes sense. It's are we talking from here to here? Yeah, so what they did, they just this is like an integral question, but what they did is they first changed it with a minus, so they put from t to a being 0, and then you would have computed the limit up top, so it would be the same as going to infinity because of 0, because the function looks like this. ln of 0 is minus infinity, so that's why they changed it. But that is completely outside the point. That has nothing to do with solving differential equation. So you have this thing equal to this thing. And here you can say, straight out the bottom, okay, integral of you can just pull it out and say integral f of t dt from point B is equal to minus 2m t minus m ln of t small t ln of t. You might be able to write that. Would you get points? Might even get all of them. But you got to keep in mind that you are gambling at this point. Why are you gambling? Because you have no idea what happens to f of a when f of t when t goes to 0. That is something really ugly that I do not wish upon you guys to solve. Yeah, I don't want to get into that discussion. It looks ugly to me. But so you don't know what that is because you have. It's a little bit uncomfortable. I don't know. It's in this case the argument just writing this out. Some graders might subtract a point or two. Some graders might be like, "Yeah, sure, that's fine." So I don't know what it is. One immediate even if you suspect this, like if you suspect this is the case, I would recommend at least writing, oh, I just observed magically that derivative of 1 to m minus m t minus m ln of t, derivative of t is just equal to the f of t minus 1 minus m ln of t ln of t. Now, you don't, so you just write something like this, which is this is just f of t. Using point B, I observed, I would write it something like using point B, I observed this thing. Okay? Using point B, I observed that the derivative of that thing is equal to that thing. You don't need to compute. You just need to show the grader that you thought about it. You thought that it might be weird. And, that it might not, that this case is the limit of an integral. That's really sketchy. So you can just work around it, or out using, this phrase, something like this. Using part B, I observed this. So this means automatically that integral f of t is just dt is just equal to that thing. Okay. Now, if you write this, if you just write this, 100%, all the graders will give you maximum points for this. If you just write this, you might lose a couple of points, okay, because you're not convinced. But if you write everything, you at least show the grader that you thought. In this case, it's not clear what the primitive is, and you actually spent a minute to think about it. Okay. Because it's a limit of an integral, it's very ugly. It's very ugly. Like the limit of integrals, I hope you don't get on the exam. I don't like working with them either. So now coming back to our solution, to our problem, we had e minus x is equal to integral f of t dt. I know from this, from part B, so minus e minus x is equal to just minus 1 to m t minus m ln t plus a constant. So x is just equal to, minus goes away. So x is just equal to minus ln of 1 to m t minus mn ln t plus the constant. And you're done. X of t here if you want. And you're done. So yeah, this is the whole problem. And they give you the solution. You just gotta show the grader that you just spent a minute to think if that actually is the solution. Okay. Just spend a minute and be like, yeah, I thought about it. It looks like the derivatives work. That's the solution. Yeah, but that's kind of all that I have to show you for, I guess, more or less all integrals and differential equations. You feel free to do the next one. This is clearly here instead of y, it's clearly an x. I don't know what y is. It's clearly an x. You can solve that. That obviously is the separable case. No, the linear case. But yeah, or we're out of time, so you can do that at home if you guys want to. Other than that, that was all from me. Next week I think you're studying linear algebra. So thanks for coming and good luck.